So here we are. Let's discuss factor and quadratic expressions. This concept is going to be broken down into a few different videos. This will be the introduction video. So if you can follow along, we can start from the beginning. In the case that you're completely lost on factoring, I would start here. So factoring quadratic expressions, starts with the word factor. We need to understand what it means to factor. And the word factor can refer to either a noun or a verb. So this can be a thing or an action. So let's break this word down. Okay? What does it mean to factor? The product of two numbers is the result that we get when we multiply the two numbers. So we could say that the product of 3 and 5 is 15. And this is the language that I'll use sometimes. Every now and then I might say something more informal like 3 and 5 multiply up to 15. But it would be more academic to say that the product of 3 and 5 is 15. And so this word, we'll use that interchangeably. Now, when we think about the word factor as a noun, we think about the actual numbers that when we multiply them produce another given number or quantity in this case. All right? The quantity that we're going to get is going to be our quadratic expressions later on in this video. Okay, but the factors, if we just think of numbers, we would say that 3 and 5 are factors of 15. So in this case, we're thinking of the word factor as a thing. Okay, but the focus of this video will be factoring as a verb. Right, so we would understand that because 3 times 5 is equal to 15, we can say that 3 and 5 are both factors of 15. So that's what the word factor means as a noun, right? These two numbers we multiply and we get 15. But the idea that we're working on here is factor as a verb. So that means to write an expression as a product of other expressions, okay? And these are the mathematical definitions. Obviously, the word factor has other meanings if we think about it just in like other academic areas. But in math, we're going to use this idea of, say, factoring a number. Say I wanted to factor 15. This is an action now, right? The process of taking 15 and writing it as a product of two other numbers. So I could say that I factored 15 because I wrote it as 3 and 5. And in this case, these are the factors, right? 3 is a factor and 5 is a factor. And so I factored 15. So we want to make sure that we're clear about the definition. Okay, what does it mean to actually factor something? And it means to write an expression as a product of other expressions. Maybe they're binomials. Or in this case, maybe it's just a number. So again, most of the time that we're factoring a quadratic expression, we'll probably be starting with the standard form quadratic expression, and then we're going to change it into factored form. And so the idea is that you need to know what A is. We need to be able to identify that just by looking at our standard form. And in this case, A represents the coefficient of the quadratic term. So we look at our variable that has a square next to it, and we see that A is the coefficient. So whatever number we see in this place would be A. B is the coefficient of our linear term. Okay, again, this variable has an exponent of 1, and it's an invisible one. We usually don't write that, but it's there. And C, again, is the constant term. So that's the term that has no variable when we're looking at an expression in standard form. So let's go look at an example. Here we have this expression that I've written, which was 3x squared plus 4x plus 5. And we should be able to identify the letters A, B, and C. We should be able to identify these coefficients by looking that the number in front of x squared, right, our coefficient of our quadratic term is 3. The coefficient of our linear term is 4. And our constant value, right, this one that doesn't have an x here, that's 5. So that's, an important step, making sure that you know how to identify A, B, and C by looking at the coefficients. So another example we have here, we have A, which is 5. We have B, which is 10. And C, which is 15. Again, these are all positive. So the signs are important here. In this case, they're positive, so we have all positive numbers. Okay, and again, the a is just the coefficient of the quadratic term, and the b is the coefficient of the linear term, and 15 is our constant term. Okay, so again, we look at another example, and this example shows what happens when there's no a value written right here, right? In this case, x squared has an invisible 1. So we want to know a lot of the times that we write these, if there's no number written there, then that means it's an invisible 1. If the x squared is there and there's no coefficient, then we consider it to be a 1. Okay, and in this case we have b is equal to 6 and c is equal to 9. Okay, so again, the coefficient of our linear term is 6, and our constant term, the one that has no variable, is 9. So if we were going to factor this, we have this idea called the magic X, and this thing that we use to help us organize our numbers, our calculations visually, right? So when we're using the magic X method, what we want to do is multiply a times c, and we write that product up here. We write those numbers when we multiply them. When we do a times c, we write that number in this spot. We put ac, and in this case, a is 1, and c is 9. So if I multiply 1 times 9, I get 9, and that goes in this case. And then here we have b, which is equal to 6. Okay, and we want to understand that I want two numbers. What we're looking for in these two spots right here is going to be us trying to find two numbers that go in this place that have a product of AC, which in this case the value is 9, and then the same numbers that we write in these two blank spots in the X are going to be two numbers that we want to have them have a sum of positive 6. So to say that in less academic language, we could say we want two numbers that multiply up to 9 and add up to 6. So sometimes you'll be able to guess this, okay? But other times when the numbers are larger, you kind of have to make a list and think about it. So usually we'll make a list of factors of AC, and we'll look through them and we'll see which ones have a sum of 6. Again, which ones add up to 6? Well, 1 plus 9 is equal to 10, not 6. So this pair of numbers does, have a product of 9, right? They multiply up to 9, but they don't add up to 6. So we move into the next numbers on the list, the next pair of numbers. 3 times 3 equals 9, and 3 plus 3 does equal 6. So in this case, we found the numbers we're looking for. So we would write these numbers in these spots in the magic X. And now when we go factor this term, since both these 3's are positive, we would go write these two binomials. We would write x plus 3 and x plus 3 in both cases. Okay, so in this case, we could simplify that one more time, and we could write it as x plus 3 squared. And we would only do that in a case where we have the same expression written twice. In this case, both of them are x plus 3. So in the next example, you'll see instead of writing the product of and sum of, I'm just going to write the multiplication symbol. I'll just put a little x in this case. And down here, we'll put a little plus symbol so that we can be reminded what we're looking for. Okay? So we have a new equation. And we see A, again, is an invisible 1. C is a 20. And so what we're looking to do is figure out what AC is. In this case, AC is 20 because 1 times 20, right? A times C, 1 times 20 is 20. So we write that here. Our B value is 12. Again, the coefficient of the linear term is 12, so we write 12 right here. So now what we have to do is consider all the factors of 20 and try to find ones that would have a sum of 12. Okay, and as we look through this list, we see that we have 1 times 20 equals 20, but 1 plus 20 equals 21. It doesn't equal 12. So in that case, we look to the next one on the list, okay? We can see that 2 times 10 does equal 20, and 2 plus 10 does equal 12. So again, we found the numbers that we need to factor this expression. Okay, we have 2 and 10, and we would write them in our magic X right here. Now, we would go factor this expression by writing it as x plus 2 times x plus 10. And again, in this case, as I said, the 2 is positive and the 10 are positive, and that's why we have our 2 and our 10 right here. So these are some basic examples that we're going through. Now, what would happen if we had a negative in the middle? So you see that this time we have almost the same numbers, but this time we have a negative 12, and so B is negative 12. So we look through the same list of numbers, but in this case, we see that we need something else to happen, right? In this case, if I do positive 2 plus 10, I won't get negative 12. But if I was to do negative 2 plus negative 10, I would get negative 12. And so we got to understand that adding up negative numbers is the same thing as doing negative 2 minus 10. And in this case, that would give me negative 12. So we see that when we have a positive number as our product, but a negative number as our sum, that means that both of these values need to be negative. And so in this case, in our factored form, we're going to have a negative 2 and a negative 10. And we'll notice that, a negative times a negative does make a positive, but when we add up two negative values, we'll have to get a negative number. And that's our clue that we use in this case. So we'll move on, and we'll consider again what happens here when we have a negative as our product. This is the first example that we've had today where we have a negative value for AC. So, consider if I multiply two numbers and get a negative number, that means one of them must be negative. So I'm trying to find two numbers with a product of negative 10 and a sum of negative 3. And so this is our list of factors. And so there's no way that I could possibly combine 1 and 10 and get negative 3, right? If the 1 was negative and I did negative 1 times positive 10, I would get negative 10, but negative 1 plus 10 would give me 9, not 3. And if I had it the other way around, if we had 10 was negative and 1 was positive, then when I multiply them, I still do get negative 10, but adding those would give me negative 9 and not negative 3. So what we can see is that 2 and 5 are 3 apart, right? They're 3 units away from each other. And so this would be the correct idea to go with here. So when this number is negative, when our AC number is negative, we're going to be looking for two numbers that are this many units apart, okay? Whether this is a negative or a positive, we just look at the absolute value and know that we're looking for two numbers that are that far apart. And so we found them in 2 and 5. And so we have to consider now which one would be positive and which one would be negative. And since we have a negative B, right, our B value is negative here, that tells me that the larger number of these two should be the negative one, right? Because 2 minus 5 would give me negative 3. So that means if the 2 was negative and the 10 was like we have here, that wouldn't work. That wouldn't give us the correct answer, right? So it would appear that I have to go in my PowerPoint and change that, right? This one should be positive 2. And this one should be negative 5. So we take a look at that here, and we see that this gives us what we wanted to get over here in our binomials, right? We have plus 2 because this is positive, and we have minus 5 because this is negative over here. So we put those together, right? This negative 5 would appear as a minus 5 over here with x, and the same thing with the 2. It would appear as a positive 2 there. So in this case, we have a negative 10 and a positive 3. And we see the opposite happens in this case, right? Now that 3 is positive, the 2 would have to be negative. And again, it looks like I have to change this 10 into a positive 5. And in this case now, when we look at this, we have a binomial which works, right? Because negative 2 plus 5 makes positive 3. So we understand that we got to look at with the idea that when this constant term is negative, we know that these two binomials are going to have opposite signs, right? Our two numbers that we're looking for will have opposite signs for sure. So before we even start factoring a quadratic, think about what we need to have. We need to have two blank parentheses, right? That's the first thing that we're going to need to write. So every time before you get started, put two blank parentheses. Then we need to have a variable in these parentheses. and we'll look at the variable. In this case, it's x. Sometimes it might be a different variable. And then we want to think about what are the signs of these expressions. What are the signs of the constants in the binomial expressions? That's going to be the most important question. So once you get the blank parentheses, once you get the x in there, you want to think about this. So I made this table here so that we could think about I made this table here so that we could think about what was happening, and this chart will notice that a is greater than 0 in all cases. So in a separate video we'll talk about what do we do when a is less than 0, but assuming that a is greater than 0, the next thing we have to think about is what's happening here. So it says that if c is greater than or equal to 0 and b is greater than 0, right? So in this case b is positive and c is greater than 0, then this tells me that we have two positive values in this case, right? Two positives. We have x plus and x plus something. In the case that we have our c is positive but our b is negative, that means that we'll have to have two negative numbers. And in the case that we have c that's less than 0, when c is negative, then we know we need to have a positive and a minus sign. And then we'll just be looking for the right numbers to set up everything else in our problem. Okay, so note that a is greater than 0 in all of these cases, and we'll move on to the next idea in just a second. Okay, so what do we do if a is negative? Okay, so in the following video we'll talk about what to do in this case, and if a is negative, we'll factor out a -1. And so in the next video we'll talk about what happens this in more detail. And so I hope you guys got an introduction to factoring right here. I tried to make this one short, and we'll do some more practice in a separate video, but this is just the basic introduction, all right? Good luck studying for factoring, and check out the next video on dealing with negatives.